Hey y'all, this is Roy. I'm one of the founders of WMS Motor Cars, and I'm bringing you with me inside the WMS Registry. Now, this registry isn't about selling parts or selling cars. It's about the engineering process and why we chose the parts that we did. Today, we're going to start off with one of the most crucial components in our F150 Reserve series, and these are going to be the brakes. Now to you, this just looks like a regular big brake kit. What's different than anything else? To us, however, this represents months of engineering, research, conversations, back and forth to select the right part for the truck. One of the questions that we get asked all the time is, why don't you just go with drilled rotors? That's what everybody's doing. Now, while we like drilled rotors and they work, when we factor in a truck of this stature, we can't charge Lamborghini prices for an F-150. So how do we bring the most value to this platform, to this vehicle, in terms of power, in terms of appearance, in terms of wheels, in terms of stopping power, but functional stopping power, stuff that's validated, stuff that's proven, stuff that actually works, that you're gonna use in the street, into one package that makes sense. And that's where the brakes come in. Every brake has its pros and cons. For example, when we look at the drilled rotors, we think racing, we might think F1, we might think high performance, we might think all that. But that's statued around essentially a title. We're chasing a name. Now, do they work? Absolutely. I have nothing against drilled rotors. As a matter of fact, to make drilled rotors work, you have to use a lot of material on the rotor itself. So whether that's nickel or whatever they're using, because as you drill these rotors, you're essentially drilling all the way through the rotor. And as that rotor goes around the caliper, assuming I have this caliper up here and you're on it and you're on the brake, those little holes where we drilled are now creating stress points. You got to remember, these rotors get 400-600 degrees. Sometimes they even get harder than that, the heavier the vehicle. We have to account for a crew cab configuration, might be 5,500, 6,000 pounds, and a single cab configuration. But I'm not going to sit here and make two different rotors. We're just going to use one that works, one that matches the brand. It's elegant, it rides good, it's fast, it establishes a presence without having to brag about it. So in our test, we chose J-hook rotors. We didn't want to deal with the risk of what if this rotor cracks? What if, we're constantly on the brakes, we're off the brakes, or we're taking these things to an autocross, a road course. We have no idea how you're going to use this truck. You can take your wife out to dinner, your significant other. You can take your clients on business meetings. You can go to the drag strip. You might autocross your car. You might put it on the road course. We don't know. So we have to factor that in mind. Now, the difference between the J-hook rotors is this J pattern here, as it rolls over, let's just say the calipers on. Let's hypothetically say the calipers on. As that rotor turns over the caliper, these J-hook rotors, and you press the brakes, so we clamp that braking force as the rotor is rotating and you're at a stop. These J-hooks are essentially going to take all that debris, all that dirt, and spit it out. So that's why we went with the J-hook rotor, because by doing that, we're always going to have a clean surface, a smooth, a level surface. Now, before I get ahead of myself, let's pause for a second and break that down in simple terms. Imagine you're eating a bag of chips, go in the house, trip, bag of chip falls on the floor. You got Fritos all over the floor, but now you have to walk to the fridge to get something. As we are walking and we are stepping on it, let's say we're barefooted, those chips are going to crumble because the floor is no longer clean. It's no longer smooth. So we're going to take that same concept of our footprints. It's going to be constantly crushing, and we're not going to have equal pad distribution or essentially equal footprint on the ground with every step. So the same concept applies here. So assuming we had brakes that were clamping or pads that are clamping, those are going to emit brake dust. They're going to take material away from the rotor and the pad, and now we're going to create uneven surface. So what's going to happen is, you ever feel sometimes your brakes rattle or you have warped rotors? That could be a combination of debris built up over time that hasn't been cleaned. Going back to that floor concept, imagine we just kept dumping chips and chips and chips. Eventually, you're not going to be able to walk on that floor because you're going to stab your feet, or you're going to sprain your ankle because when you step on it, your ankle is going to rotate just because of the amount of dirt, right? What if we swept that floor? Just grab a broom and swept it. Spill some chips, sweep it, walk. You would get the same consistent result time over time. So it doesn't matter how many bags of chips you spill on the floor, how many Frito-Lays fall out of your hand. As long as we sweep it before we walk on the floor, we're always going to have an even surface, because all of that material, all of that debris, all of those chips are essentially going to be swept out of the way. So you have an even surface, and we're not spraining ankles and we're not getting hurt. That same concept applies here. If I have an area with J-hooks, as this rotor is spinning at high RPM, and this is clamping, we're creating individual channels, pockets of air, which in time build pressure and heat, and that's going to evacuate all of the pad compound and get it out of the way. So what does that translate to in the real world? It's even surface. If I'm in hot stop and go traffic, if I'm road racing and then get on the brakes and then I let go, another car lines up next to me, I do another road race. You got to remember, these will go from cool 600 degrees in a few seconds. We're doing that over and over and over again. We're transferring material to the brakes. We want an even surface. So the minute you let go of the brakes, or as you're braking, these J-hooks are going to catch the debris and spit it out as it rotates through the pad compound. So that is why we went with J-hook style rotors. Next, we're going to talk about our caliper design and why we picked that up for the truck. Now, if you look at these calipers, they're a little bit different. A lot of these aftermarket brake systems will come with big calipers, different material pads. So we used a 6-piston caliper in the front, a 4-piston caliper in the rear, but we integrated the parking brake, and we used stainless steel brake lines. We'll get to all of these in a second, but let's start with the front. We have 6-piston calipers on a big rotor. Why did we do that? Why do we have 6 pistons up front? Why do we have 4 pistons rear? Well, the answer is simple. When you have a 700 horsepower truck, 800 horsepower truck, I mean, we build 1,000 horsepower, 1,200 horsepower trucks at the wheel, F150s here at the shop. So when you have that and you're driving these things on the street, they need to be safe, they need to be reliable, they need to be repeatable, and they need to be consistent. That's the key word. They need to be consistent. So we have a 6-piston rotor. If I have 1 piston here and these brakes are moving around, I only have this much contact patch. Now, if I have 6-piston, 1, 2, 3, 1, 2, 3, I have an equal amount of contact patch. Why is that important? Well, the answer is simple. We just talked about this. Let's say the truck makes 700 wheel. You're doing 60 to 130 pull. You get on the brakes. The whole job is to stop that car. That truck is going to shift the weight forward because the brakes are clamping. Now, I'd rather have 6 different contact points instead of 1. So we went with 6-piston to even the distribution. Going back to the heat, these get hot. We already have a smooth surface for the pads to grab on. That's going to create a better braking feel. Remember, the job of the front rotor is primarily to stop the car. Front calipers primarily stop the truck. We went with the big brake kit to stop the truck with high horsepower, with stuff in the bed, with 4 people in the car, and 7 plus 800 horsepower. That's hard to do when you think about it on a street truck, because we need these rotors to last 25, 50,000 miles before pad changes, maybe 25,000 miles. But if I don't know how you're going to drive the truck, I have to make a compromise and say, okay, what is the best possible outcome for what we're trying to achieve. We're trying to get a 6,000 pound truck to go, I don't know, 10s, 11 at the quarter mile, and then stop in less than a quarter mile from 130 miles an hour to 0. But we need that to do it over and over again. Or maybe we need that truck to stop consistently from 130 miles because it just started a roll race at 60. And there's 4 other cars waiting for this car to line up. We don't know. Or maybe this guy is going up a hill or coming down a hill at 10,000 feet, going to sea level with the full bed and 4 people on a road trip. Right? These are all factors that we experience on the day-to-day. Maybe someone cuts this guy off during that 60 to 130 pass and he has to slam on the brakes and panic stop. Do I want that heat to transfer here and fade, meaning the pads can no longer keep up because it's getting so hot, so the fluid starts to fade and you start losing brake pressure? We don't want to do that. We have to consider all of this. We have to keep things safe. So going back to that, 6 pistons in the front to get the car stopping. The purpose of the rears, which are a 4-piston caliper, is to keep that car straight. So if you've ever been in a panic stop, the weight transfer forward, there's no weight in the back, tailgate's empty, the motor's in the front, that truck's gonna wanna do this, right? Because the brakes are biasing left and right, trying to keep that car straight. So what ends up happening is it wiggles like a fish out of water. So now the purpose of the rear brakes is if it gets out this way, boom, it'll apply pressure here, it'll apply pressure on this side, and this whole time it's biasing the brakes left to right, front to rear to try to kind of keep that car straight during a panic stop. So that's the reason why a lot of manufacturers run 4 pistons. So we went with the 4-piston rear, 6-piston front, and we added a parking brake integration. So when you stop, boom, there's a separate puck for the parking brake that's not taken away from the MIG right 60. All right, so we touched base on the J-hook rotors and why we use them. We just touched base on the 6-piston front, 4-piston rears with the logos, which I thought was a cool touch, parking brake integration. Let's talk about the actual pad compound. The pad compound these are ceramic pads. They're ceramic pads for a reason. We knew the WMS Reserve F150 was going to come with forged wheels, and those will be here any minute now. My thought, again, our thoughts were, if you're spending this money on a truck, you're gonna want it to look good. The truck's gonna come with nice wheels. It's gonna be black. It's gonna be lowered. It's gonna have a nice stance. It's gonna have a lot of power. It's gonna have a lot of creature comfort, a nice interior. I don't want you to have to spend time cleaning off the brake dust on your wheels. So a ceramic pad is very similar to the ceramic coating that you would see on a car. It repels water, it repels debris, it repels dust. So the compound of that is ceramic. So as it clamps down, we're not seeing as much dust necessarily. What we're seeing is pad transfer and a little bit of debris, obviously from it wearing down. But it's nothing like traditional brakes or older brakes on regular cars that they just cake the whole car up. They just cake your wheels up. The truck comes with forged wheels. We want them to look good. We don't want them to be fading in 5 years or 1 year or 2 years. So let's go ahead and go with the ceramic pad. Let's give it a surface where it's constantly cleaning itself. And the goal is, so you have cleaner wheels, you have better stop, equal stopping power, all across the board, no matter what you're doing. I think the biggest difference here between us is a lot of these companies open up a catalog and they say, hey, what brakes fit these trucks? Here you go, have a nice day. We started with the truck and then we asked, what brakes does this truck deserve? And that's the difference between a regular truck and a reserve truck. All right, y'all. I hope you guys enjoyed this series of the registry. I plan to bring you guys with me in the office to have some of these private talks for our registry group. So if you have a friend, if you're interested in owning one of these trucks, you want to put a reserve in or deposit, if you're a dealership that wants to carry this, make sure you bring them into this group. My plan with this group is just fill it with tons of value, explain why each component went on the truck. And at the end, when you see the full truck out in the wild, out in acceleration, out at the track, out at dinner and restaurants, you'll understand what each part on that truck does and why was it selected. It's part of the ownership experience. It's part of the experience. I am going to teach you. I'm going to bring value. I'm going to educate you. And at the same time, we're going to build a community. So make sure you invite anybody who you think would like this into our group. Make sure you share news. And if you're interested in putting a deposit down or learning more about pricing options available for these trucks, definitely reach out. The next series of videos is just going to be more and more. We're going to dive into suspension. We're going to dive into the interior. We're going to dive into power adder. We're going to dive into how we set the suspension up. We're going to dive into all of this with our performance background, step by step at each registry truck. See you soon.